So let's check out these tamales right here. We're going to be graphing these inequalities right here, and these are in set notation. So check this out here. We're going to be graphing these on the number line. So this, again, the way that we're going to read this in mathematics is the set of all x values such that x is greater than -4. So we're going to graph every single x value with this restriction, but only where x is greater than -4. Okay, so if you go to -4, which is right here, we are going to be putting an open circle, and I'm going to go over the reason why we're going to do an open circle in a minute. Okay, so this is where we start -4, and we want all x values that are greater than -4. Well, numbers that are greater than -4, well, don't they go to the right? This way, correct? I mean, think about it. Is -3, -2, -1, 0, 1, 2, 3. Are all these numbers right here? Check out all these right here. Are all these numbers, are they all bigger than -4? Well, they are, right? I mean, plug it in. Is -3 bigger than -4 or greater than? Is -2 greater than -4? Is -1 greater than -4? And the answer is yes, it is. They're all greater than. So the way that this works here is you're graphing according to whatever side that makes this true. All x values that are greater than -4. Well, that's -3, -2, -1, blah blah. So I want you to notice why I didn't highlight -4. Because if I were to plug in -4 right here, -4 greater than -4, is that true or false? Is -4 greater than -4? No! False! Yeah, the answer is false, right? This is not true. So what we do is this. We're gonna draw an open circle, which represents that it's not equal to -4, but it's right next to it, like -3.99999999999, like it's really close right here, but not quite at -4. Okay, so we do that when there's no line right here. As a matter of fact, let me just make a little like answer key right here. So if you ever have an inequality that's less than or greater than, you're always going to use the open circle. So you're going to use the open circle. But though, if you have less than or equal to or greater than or equal to, you're going to use a closed circle. So you're going to use closed circle. And I'm going to demonstrate that on this next example. So check this out. I want to graph all x values such that x is less than or equal to 3. So I go to 3, and I'm going to put a closed dot. It's going to be closed. Why is it closed? Because look, closed ones because it has the little line underneath it. Okay, so it says x is less than 3. So numbers that are less than 3, what x values will be less than 3? Wasn't that 2, 1, 0, -1, right? So just go ahead and put like a little arrow right here, and bing, and there we go. Cool beans. Let's do one more here. All x values such that x is greater than 7. So since it does not have a line right here, we're going to go to 7 and do an open circle. X is greater than 7. What x values are greater than 7? Well, 8, 9, 10, right? So I'm going to put an arrow going to the right. Oops. Let me try to fix that. Okay, there you go. And there we go. So like x is greater than 7. Now, so we're done graphing these, but what I do want to just do real quick here is, so these are in set notation with these set braces. But you know what? You can also write these in interval notation, and I just want to show you how to do that. Like how would I represent this in interval notation? This is called set notation. I want to write this in interval notation. So I'm going to write or. So I'm going to write the exact same thing, just in a different notation called interval notation. And what you do is this, okay? And if it has an open circle, and maybe like I'll do another answer key, but I'll do that after I do all these examples. But since it has an open circle, I'm going to use a parenthesis and put -4, comma, and then what number does this go to? Well, it goes to infinity, so that means we're going to use the infinite symbol, and then you're going to use parentheses. You say, what the heck, dude? Whoa, man, you need to calm down, dog. Alright, so check this out. If you ever had an open circle, you're always going to start with the parenthesis. You say, well, why? Well, the parenthesis in mathematics represents numbers that are not included. And didn't we agree that -4 was false, right? Like, you can't include -4 in this inequality right here. So if a number is not included, then you're going to always use a parenthesis. Okay, hopefully that makes sense right there. Now, what about this infinite? Well, infinity, can you ever obtain infinity? Well, no, right? Because it's just, infinity is a representation of all numbers. It's just like, you know, okay, like it just keeps going and going and going and going, right? So since you can't obtain infinity, we're always going to use a parenthesis because it's not included. So this is the way that we're going to represent that. Okay, well, check this out right here. Let's write this in interval notation. Okay, so we start with the smallest number first. Okay, well, the smallest number, is that going to be 3 or is it going to be way out here because the arrow goes to the left? Well, it's going to be the one over here. So it starts with negative infinity, again, because we start from left to right, or from the smallest. So the smallest one's way over here at negative infinity, and then it goes all the way to 3. But now, since 3 is included, we're going to use a bracket. Ah, you a little bit of a trickery. So that's going to be a bracket right there. How about right here? So the smallest number is 7, right? Let's say we start with 7. So that means we're going to do a parenthesis 7 because it's not included. And it goes forever to the right, so the infinite symbol with another parenthesis. So again, so we use the brackets when the number is included. Okay, so when the number is included or a closed circle. Okay, so see right here, closed circle, bracket, open circle, parenthesis. And we use the parenthesis when the number is not included. And I'm trying to erase this here. Okay, there you go. When the number is not included or infinity. Okay, so if it's not included, and I'm going to put parentheses, and that's going to be an open circle, then you're always going to use parentheses. And also, if it's infinity, then it's going to go on forever, which means it's going to be parentheses as well. Okay, let's take a look at this example right here. Example number 9. So let's write these in interval notation and graph. So just basically what we just did right now. So this is the same thing, or we can write this as, let's go and graph it first, and then we'll do that. So let's start at a -3, and we're going to use a open or closed. Closed, right? We're going to use a closed. And it says x is less than -3. So numbers that are less than -3 go to the left. So the way that we can write this, again, you always start with the smallest number right here. So it's going to be negative infinity to -3 bracket. So see if this makes sense. The left side is always the smallest number of our graph. Well, the smallest number that this goes to, it keeps going over here to negative infinity. And so that's why we start with negative infinity. And then this number is how far does our graph go to the right? Well, the number goes, and it stops at -3, you see? And so I'm going to do a bracket because it's a closed circle. So here we graphed it, bing, and we wrote it in interval notation. Same thing right here. Let's just go ahead and we'll just start with the interval notation here. So watch this. This number says x is greater than 5. So that means that we start at 5 and we go to infinity. And if you can't quite see that yet, watch. If you graph it, you'll see that. We go to 5, open circle, because it doesn't have the little line underneath the inequality. X is greater than 5. So numbers that are greater than go this way. And does this make sense? The smallest number is 5, so bing, open circle, parenthesis. And it goes on forever to the right, so all infinity will always have a parenthesis right there. Okay, And let's go ahead and do this last example right here. Write it in interval notation and graph it. So I'm going to start at 0 with the closed dot, and it's less than 0 going that way, right? X is less than or equal to 0, so it's equal to 0, right, because of that little line right there. So put a closed dot, and it goes to the left because it says X is less than. Numbers that are less than 0 go that way. And so the way that you can write this is you can say, oh, it goes from negative infinity to 0 with a bracket right there.